Welcome to This Explainer. Today, we're tackling a massive, honestly universal frustration with current AI. You know the one, right? Why it literally forgets what you told it just last week? We are going to explore a fascinating new approach that aims to fix this goldfish memory problem once and for all. Let's get right into it.
Think about that totally relatable experience of interacting with an AI over multiple sessions. You might be deep into a long-term coding project, or maybe you're planning a complex vacation, only to realize your AI assistant has completely lost the context of your previous chats. No way around it, you find yourself constantly repeating your preferences or re-explaining the entire background of your project. It's exhausting, and it completely breaks the illusion of a continuous, helpful partnership, doesn't it?
So, behind the scenes, engineers who are trying to fix this face a really fundamental technical dilemma. They're basically stuck between a rock and a hard place. On one hand, you have bloated memory. This is where you just store raw conversations exactly as they happen. Sure, it retains all the info, but it creates these redundant, noisy, and extremely expensive raw transcripts that just immediately overwhelm the system's context window. On the other hand, you have what's called lossy abstraction. This is where the AI continually condenses and summarizes your past chats. Sounds good, right? Well, while it saves space, it inevitably discards those fine-grained details. And worse, it accumulates errors over time, causing the AI to literally hallucinate facts about you. Not ideal.
But to solve this, researchers at the University of Science and Technology of China have proposed a real game changer called Atommem. It's this brilliant framework designed specifically for value-dense storage and stable memory evolution. Essentially, it overcomes that bloated storage of the first method and the isolated, lossy matching of the second method. How? By organizing your information into structured associative graphs. The entire foundation of this whole system rests on one absolutely crucial concept, and that is the atomic fact. Think of this as the core, self-contained semantic unit of the Atommem system. Instead of storing a messy, rambling transcript of a conversation, Atommem extracts these high-value facts. They act almost like highly precise, self-contained sticky notes of information that filter out the noise and completely resolve any conversational dependencies.
Okay, so to create these perfect little units of memory, the system uses a specially tuned fact executor. It processes your raw dialogue through 3 really distinct steps. Step 1, denoising. It aggressively removes all those conversational fillers, the greetings, the fluff. Step 2 is resolve references. So if you say he or it or last Friday, the system looks at the metadata and explicitly writes out the exact name or the specific date. And finally, step 3, rewrite in the third person. So if you type, I got my bachelor's from UCLA in 2020, the system strips away all the chatter and just stores the objective data. The user's bachelor's degree is from UCLA in 2020. It's clean, it's precise, and it's totally objective.
Now, what's truly fascinating is how Atommem maps out the mind of the AI. It does this by structuring these individual facts into a much bigger, hierarchical picture. It doesn't just dump all these newly minted atomic facts into some giant bucket. Oh no. It organizes them to support high-density storage and incredibly efficient retrieval later on. It's like a giant, super-organized filing cabinet. The first way it groups these facts is into what they call episodic events. This is basically the AI's contextual memory. It groups logically aligned atomic facts into coherent narrative blocks over time. For example, if you mention booking a flight on Monday, looking up hotels on Wednesday, and packing a bag on Friday, Atommem naturally connects those scattered atomic facts into a single vacation event. This is absolutely crucial because it maintains the contextual continuity of your broader experiences, keeping the whole narrative intact. Right alongside those narrative events, the system also builds temporal profiles. This is a dedicated memory layer that dynamically tracks your stable user attributes, your preferences, and your habits. It notices if you mention a peanut allergy or, that you live in Seattle. And brilliantly, it tracks how these things evolve. If you later move to Boston, it updates your profile, but actually keeps a historical record. It's just like a human friend getting to know you and remembering how you've changed over time. So, okay, we have this beautifully structured data, but structuring is really only half the battle, right? We need to understand how the system actually recovers these fragmented clues when prompted. How do these isolated facts actually form a bigger picture when you ask the AI a really complex question weeks later? To solve this, Atommem activates an associative memory graph. I want you to picture a detective's corkboard, with the red string connecting all the clues. That's exactly it. The system draws lines, or edges, between facts in 3 specific ways. First, entity edges connect facts that share specific keywords. Then event edges connect facts that share the same coherent episodic background, even if they don't share exact words. And finally, temporal edges connect facts that were spoken in adjacent dialogue turns. This multi-layered web allows the AI to naturally trace a train of thought across months of conversation. It's so smart. Now, when it's time to actually formulate an answer, the system uses a three-stage hierarchical strategy to synthesize the perfect response. First up is primary recall, which directly matches your question to the most obvious atomic facts. Next is compensatory recall. This looks at the broader event layer to pull in contextual clues you didn't explicitly ask for but definitely need. Finally, it uses associative recall. This activates that memory graph we just talked about, letting an algorithm basically wander through those red strings to find indirectly related but vital pieces of information.
And wow, the payoff for this structured approach is massive. By converting bloated transcripts into clean, atomic facts and retrieving them hierarchically, Atommem achieves a staggering 61.4% reduction in total token consumption compared to previous state-of-the-art systems like Mem0. Let me say that again, over 60%. Because it isn't forcing the AI to reread thousands of words of ums, ahs, and relevant tangents, it saves an absolutely incredible amount of both money and computing power.
And the best part? It absolutely does not sacrifice quality for that efficiency. The performance on the challenging Locomomo benchmark clearly proves this. Now, this benchmark evaluates very long-term conversational memory, featuring interactions that average over 600 turns across 35 distinct sessions. It's tough. Yet, Atommem completely dominates the baselines across complex reasoning tasks. In the open domain evaluation, it scored a 64.58. That literally leaves highly respected systems like Mem0 and LightMem in the dust. But what's truly remarkable here is that the researchers even proved that a simplified kind of flat variant of their system, one without the complex graph retrieval, still outperformed standard baselines. This proved a super vital concept for the future of AI. Memory storage quality is paramount. You can build the most sophisticated search orchestration in the world, but it simply cannot compensate for flawed, noisy memory representations. Extracting high-quality atomic facts, that is the ultimate key to giving AI a reliable memory.
So, as we wrap up this explainer, I want you to consider the broader implications. We are finally moving past the era of the goldfish-brained chatbot. If an AI can now reliably build a complex, evolving map of our lives, remembering the vital details without drowning in the noise, well, how will that change our relationship with technology? Imagine the possibilities when your digital assistant finally has the capacity to truly remember, understand, and grow alongside you over a lifetime. It's an incredible step forward. Thanks for joining me to explore the mechanics of Atommem.